recall that we were able to write down inverse tangent of x as x minus x cubed divided by 3 plus x to the 5 divided by 5 minus x to 7 over 7 plus the rest of the terms, or in compact form, series form, we have the summation of -1 to power n times x to power 2n plus 1 divided by 2n plus 1 and start from 0 to infinity. How we did that? We already know the behavior of 1 over 1 plus x squared, since we knew 1 over 1 minus x is basically the summation of x to the n, 1 plus x squared, plus the rest of the terms. And we saw that 1 over 1 plus x squared can be written as, so in that case, as you remember, this is equal to 1 divided by 1 minus x squared, and this was the quantity that we're using, which is the summation of negative x squared to power 2 and to power n, and starts from 0 to infinity, and this guy was negative x squared to power 0, which is 1, negative x squared to power 2, and you could simplify this as well. Let me just write this guy as the summation of -1 to power n times x to power 2n and start from 0 to infinity. You could write some of the terms of this series as well. And as you remember, the inverse tangent of x was basically the integral of dx over 1 plus x squared. So it basically took the integral of the term of this series, which, as we saw before, is equal to 1 minus x squared plus x to the 4th minus x to the 6th plus the rest of the terms dx, and it gave you x minus x to the 3rd divided by 3 plus x to the 5 divided by 5 minus x to 7 divided by 7 plus the rest of the terms. So that's how we derived the inverse tangent of x written in the form of power series. Now the question is, what if you have a function of this form? What if you have x squared times inverse tangent of x cubed? You have f of x, which is equal to x squared times inverse tangent of x cubed. What is the power series representation for this guy? How are we going to deal with this? You already know the behavior of inverse tangent. The inverse tangent is the summation of -1 to power n, x to power 2n plus 1 divided by 2n plus 1. But this is for inverse tangent of x. So let us copy down inverse tangent. Since inverse tangent of x is equal to x minus x cubed divided by 3 plus x to the 5th divided by 5 minus x to 7 divided by 7 plus the rest of the terms, or in the compact form, we have -1 raised to power n, x to power 2n plus 1 divided by 2n plus 1, and start from 0 to infinity. Now, wherever I see x, I'm going to use x cubed, right? So wherever you see x, you're going to use x to the 3rd, this guy here. So inverse tangent of x cubed is equal to, so wherever you see x, you're going to use x cubed instead. You get x cubed minus the denominator stays the same, the power is 3, and instead of x, you're going to use x cubed plus the denominator is 5. You have power 5 of x cubed minus, you continue this process on the right, divided by 7. The power is 7, and you have x cubed plus the rest of the terms. Okay, we can simplify this further. The inverse tangent of x cubed is equal to, so now here you have x cubed minus, so here you have x to power 9 divided by 3. And you continue the exact same process, and then eventually you can combine these exponents and write it in power series representation that you see later. So here you have plus x to power 15 divided by 5 minus x to power 21 divided by 7 plus the rest of the terms. Or in simplified version, or in more compact version, if you want to use series, let me just erase this one so we have enough space. So plus the rest of the terms can be written as the summation of -1 to power n, and here you have x to power 3 raised to power 2n plus 1 divided by 2n plus 1 and start from 0 to infinity. Or inverse tangent of x cubed can be written as the summation of -1 to power n x to power 6n plus 3 divided by 2n plus 1 and start from 0 goes to infinity. Are we done yet? Not yet. Why is that? Because you already have another term to multiply as well, which is x squared. So take a look. Now, if I take x squared, let me write down the function itself, f of x, which is x squared times inverse tangent of x cubed. You have x squared times these terms, which was x to the third minus x to the 9 over 3 plus x to 15 divided by 5 plus the rest of the terms minus x to 21 divided by 7 and so on. So for the sake of space, just leave it as it is. Or you have x squared multiplied by the series is -1 to power n x to power 6n plus 3 divided by 2n plus 1. But if you start multiplying this and you see the change in the exponents easily, this is basically distribution of x squared into parentheses for you. This guy can be written as x to the power 5 divided by 1 minus x to power 11 divided by 3 plus x to power 17 divided by 5, and the rest of the terms. Here you had x to power 21, am I right? So this guy becomes x to power 23 divided by 7 plus the rest of the terms, which can be written as the summation of -1 to power n x to power 6n plus 3 plus 2 divided by 2n plus 1 and start from 0 to infinity. So you're basically adding these two to the exponent of your x. This series can be written as the summation of -1 to power n times x to power 6n plus 5 divided by 2n plus 1 and start from 0 to infinity. So your function f of x is nothing but x squared times inverse tangent of x cubed, which is the summation of -1 to power n, x to power 6n plus 5 divided by 2n plus 1 and start from 0 to infinity. Well, what is the interval of convergence now? How do you find the interval of convergence for this series? Well, to find the interval of convergence for this series, you only need to focus on to the inverse tangent of x cubed, because x squared is already a quadratic term. Everything depends on inverse tangent of x cubed. Or if you write it this way, you can use the ratio test if you want to see all the steps, all the algebra behind it to find. Now, to find the radius of convergence, we can go over all steps using the ratio test. You need to find the limit of absolute value of an plus 1. Let me use a different color for an plus 1 over an. As n goes to infinity, very good. So let us begin. You have the limit of the absolute value of an plus 1, which gives you negative 1 to power n plus 1, times x to power 6 times n plus 1 plus 5, divided by 2 times n plus 1 plus 1, divided by, here you have negative 1 to power n, x to power 6 n plus 5, divided by 2n plus 1, close up the absolute value, and n goes to infinity for you. Okay. Since it's absolute value, you don't have to worry about the negative 1 raised to different exponents. Just simplify this as much as you can. So here you have the limit of the absolute value. So we can multiply these together and then simplify. Either is fine. So you have 2n plus 1 times x to power 6n times x to power 11 divided by, what I did, I just distribute this into parentheses and add 5 to it, divided by 2n plus 2 plus 1, which is 2n plus 3, multiplied by, here you have x to power 6n plus 5. X to power 6n times x to power 5. Let's close up the absolute value and find the limit as n goes to infinity. And this limit, as you remember, must be less than 1. So this guy must be less than 1. Okay. So this limit is the limit of the absolute value of 2n plus 1. n plus 1 divided by 2n plus 3. When n goes to infinity, close up the absolute value. Why is that? Because here you end up with x to power 6 to 6n and x to power 6n, they get cancelled out, and you end up with absolute value of x to 11 divided by x to 5, which is nothing but x to power 6. And this guy must be less than 1. Now we get to the point at the beginning I told you it all depends on the inverse tangent, and x has nothing to do with this. So take a look. The limit of 2n plus 1 divided by 2n plus 3 when n goes to infinity is equal to 1. You end up with the absolute value of x to power 6, which must be less than 1. But if you take the 6th root of both sides, the absolute value of x must be less than 1, or x is bounded between -1 and 1. So the interval of convergence is open interval -1 to 1, usually represented by open interval -1 to 1. So to summarize and recap what we did, we had this function. This is our function x squared, inverse tangent of x cubed. We already know the behavior of inverse tangent of x, which is x minus x cubed divided by 3 plus x to the 5 divided by 5 minus x to the power 7 over 7, which in series notation is the summation of -1 to power n, x to power 2n plus 1 over 2n plus 1. So inverse tangent of x cubed, wherever you see x, you're going to switch it with x cubed, simplify as much as you can. You end up with the series of -1 to power n, x to power 3, multiplied by 2n plus 1, divided by 2n plus 1. So the power series representation for inverse tangent of x cubed is the summation of -1 to power n, x to power 6n plus 3 divided by 2n plus 1. Your function has x squared multiplied by inverse tangent of x cubed. So we basically distributed x squared into parentheses, and you only see the change in the power of x. Nothing else is changing. That makes sense. When you're multiplying x squared and a power series, you only combine the exponents for x, nothing else. So f of x, which is x squared inverse tangent of x cubed, is the summation of -1 to power n, x to power 6n plus 5 over 2n plus 1. For the interval of convergence, it all depends on inverse tangent of x cubed. But I showed you step-by-step work how to use the ratio test as well to check the convergence of this series. We went over all the algebra. This limit must be less than 1. The absolute value of x to the 6 must be less than 1. If you take the 6 root of both sides, absolute value of x must be less than 1, or x must be bounded between -1 and 1. This is the interval of convergence for your power series.